Welcome to today's presentation. This slide doesn't contain enough information. That's why we're moving to the next slide. Let's go through the numbers less than 20 and identify which ones are prime. Remember, a prime number has exactly two factors, one in itself. Also, note that 1 is not considered a prime number. Starting with 2, it's prime because its only factors are 1 and 2. Next, 3 is also prime for the same reason. Factors are 1 and 3. Moving on to 4, it's divisible by 2, so it has factors other than 1 in itself, meaning it's not prime. Similarly, 5 is prime because only 1 and 5 divide it. Now 6 is divisible by 2 and 3, so it's not prime. 7 is prime again with only 1 and 7 as factors. Numbers like 8, 9, and 10 are divisible by other numbers. 8 by 2, 9 by 3, and 10 by 2 and 5, so they are not prime. Moving further, 11 is prime with only 1 and 11 as factors. 12 is divisible by 2, 3, 4, and 6, so it's not prime. Then 13 is prime with only 1 and 13. Similarly, 14, 15, and 16 are divisible by other numbers, so they aren't prime. Next, 17 is prime, only divisible by 1 and 17. 18 is divisible by 2, 3, 6, and 9, so it's not prime. Finally, 19 is prime because its only factors are 1 and 19. So the prime numbers less than 20 are 2, 3, 5, 7, 11, 13, 17, and 19. These are the numbers that meet the key definition of prime, having exactly two factors. This understanding helps us distinguish primes from composite numbers, which have more factors, and it ties into the broader theme of number properties we're exploring. Let's look at some examples to understand prime numbers better. First, consider 21. It's divisible by 3, since 3 times 7 equals 21, so it's not a prime. Similarly, 27 is divisible by 3 as well, because 3 times 9 equals 27, making it not prime. Now take 25. It's divisible by 5 because 5 times 5 equals 25, so again, not prime. On the other hand, 23 is only divisible by 1 and itself, which means it is a prime number. Likewise, 29 is only divisible by 1 and 29, confirming that it's prime too. Remember, prime numbers are only divisible by 1 and themselves. Now, for our question, how can we show that there are two prime numbers between 20 and 30? Let's start by listing the odd numbers between 20 and 30. We skip even numbers because, as you know, 2 is the only even prime, and even numbers greater than 2 are not prime. So the odd numbers here are 21, 23, 25, 27, and 29. Next, we check each for divisibility. 21 is divisible by 3, so not prime. 25 is divisible by 5, so not prime. 27 is divisible by 3, so not prime. That leaves us with 23 and 29, which are only divisible by 1 and themselves. Therefore, the two prime numbers between 20 and 30 are 23 and 29. Let's look at the answer first. 18, 36, 54, 72, and 90. These are all the two-digit multiples of 18. To find these, we can simply multiply 18 by counting numbers starting from 1. We keep going until the product becomes a three-digit number. Now, moving back to part 2, where we find all the factors of 18. This involves finding pairs of numbers that multiply together to give 18. For example, 1 times 18 equals 18, 2 times 9 equals 18, and 3 times 6 equals 18. So the factors of 18 are 1, 2, 3, 6, 9, and 18. Recognizing these factors and multiples helps us understand how numbers relate to each other, which is a key theme in our overall study of numbers and their properties. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide.